Let's discuss question number 32 from machine design of this test 1. So this is from machine design, basically the rivets part. So you have a riveted joint and you have a plate here. We are applying a central force F, and you have another plate here. So it's kind of a double shear joint. Okay, and you are applying F by 2, and this is how your rivets are formed. Okay, so now what is asked is the ratio of crushing stress to the shearing stress for this rivet, and this entire thickness is L. This is thickness is L, and this is also L. Okay, so now when you apply this sort of geometry, okay, when you're pulling this towards left and these two towards right, the shear happens here. So if I take only the middle plate, okay, and the rivet being this, when applying total F here, okay, this part and this part, so it's something like this. When I apply F here, the shear forces are created here and here. So this F is supported F by 2 and F by 2. So the shear stress occurring either at the top or at the bottom will be, the shear force is F by 2 by the area will be the shear stress occurring. So that is F by 2 into area is pi by 4 d square. Or the other way of understanding is this, the total force F is shared by twice the area. This is one area pi by 4 d square, this is another pi by 4 d square. So the total force is shared by 2a, is twice by 4. So this is F by pi by 2 d square is the shear stress. Now let's come to the crushing stress. Now crushing stress, you can understand, when you apply this force F wherever, the part of the rivet which will be in contact with the top plate will be this part, with the middle plate it will be this part, and with the bottom plate it will be this part. So if you consider the top plate, so this is the left half or the left half cylinder, and this will be in contact, right? Okay, now the crushing stress is defined as the total force that is supported, that falls or that is resisted by this half, the semi cylinder. So this total force by this projected area of this lateral part onto this. So it's basically your local pressure or local compressive stress. So if you imagine that pressure is acting throughout this semi cylinder, so pressure into this projected area, which is your thickness into your, this is your diameter. So into area of projected, the pressure acting into area projected is the crushing load. Okay, and that load is F by 2 for the top plate. So P is what is my crushing pressure or crushing stress. Projected area is D into L. Okay, this is for your top plate. Now same thing if I do for the middle plate, it will be crushing pressure for the middle plate into diameter into thickness. The same thing will be at this side, but the force is F. Now force resisted is F. So this is for the middle, and for the bottom it is same as the top. The P into T is the total crushing load, and it is F by 2. So now if you see from these three, P will be maximum only in the middle part, and that is your crushing stress. So max crushing stress P is F by dt. Okay, now I need to divide these two. What is asked is maximum pressure by shear stress. So F by dt by shear stress, which is F into pi by 2 t square. So t will F gets cancelled, pi by 2 is pi by 2, d gets cancelled by t. Now t is thickness of the plate, which is given as L here, so pi d by 2L. So this is how. So only thing is you have to understand where you are getting the maximum shear stress and where you are getting the crushing stress. Now crushing stress is important, so and you have to analyze in this way. Okay, so this is pi d by 2L. Answer is A. Option is A. Thank you.